for the next set of problem, the first thing you would need to do is to try your hands on these problems from parts A through part D, and whenever you're ready, you have your set of solutions with different notations, you can go ahead and restart the video and we'll go over the solutions from here. First, we're going to look at the parts A and B first together because they are the same inequalities involved and they are just connected by different words. First, we have the scenario where the two inequalities are connected by the word and. So I already drew the number line with two intervals included separately, and when we have the scenario connected by and, remember we're looking for where the number line is covered by both intervals, so where the two intervals overlap. And as we can see, they overlapped starting from here and everything beyond, or everything to the left of that point. And when we include this scenario, we can say that our interval starts from negative infinity because there's no bound to the left, and that would be where we get started. And it stopped at -2. And notice when it stopped, it's a -2 with a parentheses. That means the cutoff point -2 was not included as part of the shorter interval that we initially drew over here. So we still want to keep that parentheses. That's the overlapping part. Similarly, for the set notation, we can translate it to be x such that x is less than -2. So this is exactly the same as the second inequality we started with. For organizing the information with number line notation, we just have one cutoff point, which is -2, and we want everything to the left of -2 over here. And one thing I want to point out is in this video, I'm using the notations in this particular order that they are being asked for, but you can feel free to start with whichever notation makes the most sense or comes out most easily for you. If, say, with a number line to start with, the number line conclusion jumps out first to you, feel free to use a number line notation in your answer first. That way it'll guide you through the other notations more naturally. It just means we have different train of thoughts. Doesn't mean one way is necessarily better than the other. It's just whichever notation makes the most sense to you, whichever notation jumps out to you the most. Some people might find the set notation to be the easiest to work with and write that notation first. They should all convey the same information, so choose whichever notation that makes the most sense to you and start with that one and convert that into other notations to make sure you are practicing with all different notations. Similarly, for part B, if we have the inequalities connected by the word or, notice we are just looking for the part of the number line that's covered by at least one interval. And looking at that, we can see that the number line starts being covered by at least one interval starting from this point and beyond over here. So 3 is a cutoff value that we care about. So if you notice from the number line right away that we are just including anything that's less than or equal to 3, definitely feel free to use the set notation to start, for example. And we know we just want to state the inequality over here. X is less than or equal to 3, and to include the formal notation with curly bracket for sets, and x indicating that's a variable we're working with. Now from here you can translate it to interval notation. We have negative infinity to 3 with 3 being included. Lastly, for number line notation over here, we would include everything to the left of 3 with, again, 3 being included over here. And that would be how we insert parts A and B in different notations over here. And if you're ready for the answers for parts C and D, you can continue the video. Otherwise, take a minute to work on parts C and D first. Again, for parts C and D, I already drew the number line with two intervals kind of separately on the same scale, on the same number line. And to get us started, for the inequalities connected by and, we are again looking for the part of the number line that's covered by at least one interval over here. Sorry, for and we're looking at the interval that's included by both over here. So we're looking for where the two intervals overlap with each other. And we'll notice it's this part over here, starting from the parentheses, ends with a bracket over here, with a cutoff point being -1 and 5. Again, if you want to start with a set notation, definitely feel free to do that. We would have the cutoff value being -1, and -1 was not included, all the way to 5 over here. And notice when I'm writing this notation, I'm just writing it out as one long inequality. I'm not separating them into two inequalities anymore, because we can see if we read from left to right, we have -1 being the cutoff value, and we know x is greater than -1. So in other words, we can say -1 is less than x. And on the other hand, we also know x is less than or equal to 5 over here. And then we can just continue with x in the middle with two separate boundaries over here. So we would have x such that -1 is less than x, less than or equal to 5. That's how we would write this final result over here. In this type of inequality, when we have the variable in the middle and two restrictions on either end, this is what we call a three-part inequality, because you can see this is more than just two sides of inequality. We have three parts over here. And this is technically a part or a type of compound inequality as well over here. And in this scenario, that just means we have a restriction that's bounding the variable on both ends. This is something new, again, because we didn't have two restrictions to work with before. Now we have this scenario. This could happen when our overlapped area or our overall result ends up being bounded on both ends over here. Notice it didn't happen before because we always had the scenario where either the left side or the right side are not bounded. In this case, they're both bounded. So we have this result of three-part inequality. And now with this information, we can also write the interval notation. Because we have bounds on both ends, we would have the left side being bounded by -1, excluding -1, and right side bounded by 5, including 5 over here. That's exactly what we see in the overlapped part. And lastly, for number line notation, our variable is x still. Our cutoff points are -1 and 5. We have two restrictions. And to indicate that, I can just use one interval, just as we did before. And -1 is bounded on the left, is a boundary on the left, and 5 is a boundary on the right. And that's going to be my interval, with parentheses on the left, bracket on the right. So this is somewhat new type of problem that we encountered with how these two individual inequalities interact with each other. Now lastly, for the scenario with OR, we're looking for the part of the area that's covered by at least one interval. And as we notice, if we want to look for the part that's covered by at least one interval, we could just keep going to the left. Similarly, we could keep going to the right. We have no boundary whatsoever because these two arrows, one goes to the left, one goes to the right. So for the overall result, we can say this is going to be all real numbers over here. So if you were to highlight the number line for this particular purpose, we would need to highlight this entire thing over here. So you could just shape the whole thing with no boundary for the number line notation. And now for the set notation, because we have no boundary, that means we're starting from any number or end with any number on the number line. So we could use the set notation to say that x is just a real number. You can alternatively use the notation for a set of all real numbers. So alternatively, you can use this fancier looking R to indicate the set of all real numbers. Just choose one, whichever you prefer. This means this is a set of all real numbers. And that's how we would use a set notation in this scenario to include every single number on the number line, on our real number line. And lastly, for interval notation, we notice there's no boundary. That means for our starting point, it's negative infinity. Our end point will be infinity. So that will be our interval notation. So parts C and D are a bit more challenging because they're a different type of result than what we saw in the examples, but hopefully you were at least able to put some information together to notice the result in very different conclusions over here. And formally, these are the notations we use to represent the and or scenarios in this situation.